It's actually pretty cool to be here because I've spent a bit of time over the years in R&D organisations. I worked for DPI for a bunch of years and I've done a bunch of stuff with GRDC. So it's really kind of cool to see so many people that I've seen before and to touch base and to see how the CRC's been going. I came onto the board 12 months ago and so I've been able to see it outside and then look in. So it's been fantastic. It's really been good to sort of see what you guys have all done over the last 5 years. Thinking about needs and adoption, technology and data, new products, field applications. But we're halfway through. And these guys are going to help us to think about or to give some insights from their perspective on where industry sees this going. I've asked them to sort of really come down to one question, and I want, at the end of this, you guys will have a chance to ask some questions too, but what are the key opportunities and challenges from their perspectives? To help us with that, I've got Max Young from SAGIT, South Australian Grains Industry Trust, also a farmer. I've got Dave Brennan, CEO of Wimmera CMA. I've got Peter Wadewitz from AORA, Australian Organics Recycling Association. And I've got David Bergmann from Southeast Water. And if I finish with David there for a second, I had the question to Michael this morning, Southeast Water, what's their interest in the CRC? So we've had some good conversation about that. I'm going to walk through these questions, but Max, first of all, SAGIT, what's your interest in the CRC?
Well, I guess to outline who SAGIT is in the first place, SAGIT is a South Australian group. It was formed in 1991 with the demise of the wheat industry. The Wheat Industry Fund money came back to South Australia. It was about $4 million, and what was GPSA then was Farmers Federation. They had to work out what to do with it, and they decided to set up a trust and use that money for the benefit of research in the grains industry. So that's developed on from there. We now have a levy or a contribution that we collect from the growers of 30 cents per tonne, which raises roughly about $2 million a year. And from that, we use that for research in the grains industry, capacity building in the industry, and education and communication. So one of the things we like to do is we like to stretch that money as far as we can. So we like to collaborate with whoever we can that can add to that bucket and give us some more scope in research in South Australia. So when the idea of backing the CRC came along, we were very supportive and we got in on the ground level. Malcolm Buckby, who is our project manager, spent a lot of time and effort in forming the CRC in the first place, and our contribution to it has been $150,000 a year, which is significant over the 10 years, $1.5 million. So we want to get. We're specifically South Australian grain industry, so we want to see some work done back into the South Australian industry. So that's basically
cool.
Where we sit.
Thanks, Max. Dave, tell me about Wimmera CMA and your interests.
Yeah. Thanks, Simon. I guess for those of us who don't know what a CMA is, it's essentially a natural resource management organisation, and there's about 58 of them across Australia. Our primary role is about strategy, and it's about the health of the catchment. And the CMA, or the NRM body that I'm the CEO of, it's about delivering the vision on behalf of the board, and our vision is about creating a profitable and resilient community. And there's such a strong line of sight between the health of the soil and the health of our economy and the health of our ecosystem that we have to be right across all the challenges and opportunities with soil. So when the soil CRC was announced, we were keen to be partners just because of that strong line of sight with our organisation. And I guess to put it in perspective, 85% of our land mass is agricultural. So it has a big impact on our community.
Thanks, Dave. Peter, you've been around doing recycling of organics for a long time. Tell us about your AORA and your interest in the CRC.
I was with some Indonesians yesterday and a young girl said, "You've been involved for this for 50 years?" And she said about 10 times, 50 years! So thanks very much for this opportunity. Look, I've been really excited about this project since the day I started with Michael. So I wear two hats here today. AORA, chairman of AORA, which is the compost industry of Australia. There's about 75 composters around Australia. There's a couple of hundred members in our association. We had a conference here a couple of weeks ago. We had 250 turn up at the conference. Michael came along because we're trying to link the compost industry with this to make sure that our compost that goes out will go out in a much better grade, make sure that we're designing products that will fit all the science that you're applying. How can we improve compost? How can we get it out to the farmer in a much more economical way? And then, of course, the bottom line of all that is how do we make sure that we get return for investment for the farmer, etc. We're recycling about 6 to 7 million tonne in Australia. There's probably another 15 million tonne or more going to landfill. So we're trying to make sure that we can get that material out. The federal and state governments are working on that in terms of policies. So we've got to get a bit smarter on how we recycle it and how we turn it into greater value.
Thanks, Pete. David, you and I have got to know each other. Tell us about it.
So South East Water is one of Melbourne's metropolitan water retailers, which means we take water and we send it to our customers. We own the pipes and the network, the digital meters, so we send the bills, and then we take the sewage away and we treat it, and we do that. So we're one of Melbourne's. We have industrial businesses in our catchment, we have residences, but we also then join on to farmland and agriculture of Central Gippsland and South Gippsland as well. So as a water retailer, we send your water, we take your sewage away, and we treat that. And we end up with recycled water, class A, B, C, great use in agriculture as well, but also we end up with the solid part of the number twos that's been sent to us. And so that is, we can see that as a waste product, or we can see that actually as a product that can be used. And we have a vision as an organisation about the way we participate in the circular economy. And so to do that, we need to engage with agriculture to be a part of that, and hence being a part of the soil CRC. So seeing as, I suppose, you all make a contribution to sewerage, so you can all make a contribution to solving the problem as well.
Thanks, guys. Before we throw it open to that opportunities and challenges piece, what have you enjoyed out of your involvement in the CRC so far? What have you got out of it, guys? This is the industry panel, but Dave, you mentioned to me before some of your experience out of it.
Yeah, thanks, Simon. So I guess we've been involved with Hannah-Beth Luke's work looking at landholder data, and we've been fortunate that we've run that survey for 4 iterations. And that is really powerful market intelligence when you're designing projects, particularly for government investors. And we've been able to essentially mine that data and create a range of products for farmers in particular, where the Wimmera CMA has delivered the most market-based incentives in Australia. And we have formal contracts with over 30% of the farmers in our region to improve land management practices. So that's just one example of how the survey work can actually be used to literally transform catchments.
Max?
What I neglected to say before was the way we distribute our funds is through an open call system. So we actually don't look at ideas and say we want you to spend money in this particular area. We just say to everybody, we're here. You give us our ideas and we'll pick the best of what you got. And we collaborate with the universities, with SAGIT, with the grower groups, and with private agronomists, and we work with all of them together. And so I think that what the CRC has given us is that ability to also collaborate, and through the work that Nigel's done, we've also been able to get extra money in from GRDC to work on that, and as Nigel presented, the alkaline soils and those high carbonate soils are a major issue for South Australia. So that's been great, and the other thing, being able to get a couple PhDs into South Australia has been great. It's been a massive challenge because we were unable to get any universities from South Australia to come on board. So to be able to get to announce that we've just got 2 PhDs been awarded to South Australia, one working with Enzo Lombi, and he works in the area of developing and we do 2 projects with him, and I think the PhD student, whose name is Vijay Arala Panavar, and also Mick Rose from New South Wales is involved in this project, and we're doing 2 projects that are outside of the CRC, but the PhD student will be working within them. One of those projects is to develop a DGT methodology to assess bioavailable herbicide residues, and the other project he's doing is comparative effects of agricultural chemicals on South Australian soil microbial functions. So that will be great to develop somebody else in that area. And the second project will be with Adelaide University, and the student will be Stephen Lang, and the supervisor Timothy Caviano, and they'll be working with Nigel Wilhelm in that alkaline soils work that Nigel presented. So there's some great successes of what we'll be able to get put back into South Australia.
David, your experience of some wins?
With some wins, or?
Yes. What have you experienced out of your involvement so far?
Yeah, okay, sorry. So I think one of the things we've enjoyed most about the involvement with the soil CRC has been, don't take this the wrong way, water industry is a great industry to be in. When you go to water industry conferences, and even some of the water industry based CRCs and ARCs, it's the usual suspects, which means the same kind of ideas get recycled, the same kind of thinking. By being part of the soil CRCs, I personally know very few people in the room. It's a whole new network. It's a whole new range of researchers and thinking and ideas for us as a water utility, which is great. And then just the range of groups here, from the farmers groups to the researchers, it's a fabulous collective, which we've got a lot out of that engagement so far and can see more coming.
Yeah, fantastic. Pete, you got?
Yeah, the work we've done with Amanda Chappell in terms of the dry, non-wetting sands, etc., has been really, really good, and I think we've got a long way to go there. Even developing products again that will help with that is really, really exciting, and some of that work is going to continue for quite a long time. We're already getting orders from farmers because of that work, which is really the link that we wanted, and we're trying to then redevelop those products again to make sure they fit for purpose. We get a lot of farmers now that want compost blended because of all the science that's going on. Farmers that want DAP and MAP blended, gypsum added, biochar added, etc., to compost, and that's all coming out of this work. It's bad luck that we've had 2 years of bloody interruption because of COVID, because I think we need to get this information out there both to composters and also to more farming information.
So, Mark, I couldn't have scripted that, but Max, straight on to what are the opportunities, right? Like Pete's mentioned a couple there.
I guess I would start with the challenges. The challenge is just getting it out into the farmer's paddock, like all the information, all the science, all the technical information that we've been fed today. A lot of it is sort of at the hypothetical level. To be able to change that to get it to an economically feasible thing for a farmer to do next door neighbour here has been working for 50 years. This is my 40th season putting crops in the ground. When I go to field days, I look at all the technical information, but at the end of the day, when I drive out the gate, I think, what can I actually turn into something that works for me tomorrow? And that's the challenge of the CRC, is to actually make it work for farmers. The opportunities are wide and varied. This is such a complex field, and in South Australia we've got so many different soil types. The calcareous soil types is just one, but we've just got massive soil types, and then you know, how much can we spend money improving the soil compared with just accepting that the constraints there and using variable rate and zoning to be able to just change our input costs on certain areas.
Thank you. Dave?
Yeah, many opportunities, and I guess firstly I'd like to say I've been suitably impressed by a lot of the presentations this morning, the amount of innovation, new ideas, the opportunity for commercialisation to make a significant difference. It cannot be understated what we've seen today. I'm going to go away, totally inspired. But what I'd like to draw my attention to, and it's going back to the primacy of our organisation, and this will be an important point for some of the students and potentially the next CEOs coming through the system, is you never want to be caught out when something's happened and you haven't seen it and you've missed it. And I can't help but think at the moment, everywhere I go, it's about soil and carbon. You turn on the kind of ads at night and it's about coals. They're going towards net zero, and they're looking at a reduction of the kind of 75% of their scope 1 and 2 emissions. And so we can see that means that's going to be pushed back to the farmers. And I guess with the Soil CRC and through Federation University and ARIF, our PhD student here, we're working together with our local researchers, our local farmers, to say, well, what is that going to mean for the Wimmera, and how can we actually prepare our community for it? And the brilliance of this CRC is that we're using some disruptive technology. So ARIF's actually a specialist in machine learning and artificial intelligence, and we're teaming them up with our local professors and AgVic staff and other farmer groups to apply that to kind of, depends on your perspective. You can see it as a risk or you can see it as an opportunity, and we're very much seeing it as an opportunity, is how can we prepare our farmers for essentially the low carbon economy, which is going to come and hit us fair in the eyes, whether we like it or not. And I guess my job as a CEO is, when I'm reporting to my board, is I can say, well, if we want a resilient and profitable community, we've got to be all over this.
Thanks. Hey, Pete.
Just a couple of things. 12, 18 months ago, I said to Michael, what's the definition of a high-performance soil? So I'll put a challenge out to you. What is the definition of a high-performance soil? And one of the things I haven't seen in here is even a measurement of worm count, because you see it. I've got a farm. We've been putting out compost for 5 or 6 years. We actually find worms now that we never found before, and I get excited about it, which is a bit sad, isn't it? But it shows that you've got a healthy soil, and hopefully that'll turn into crop and yield and quality stuff, etc. And another statement is, I was driving to Mildura a few months ago, and there's many signs along the road going up to Mildura that says, in a sandstorm, turn on your lights. How sad is that our soil is so degraded, so poor, that when the wind blows, we've actually got to go and turn on our lights. So if we haven't got an issue in terms of getting that soil to a high performance, or in terms of those areas. So they are the challenges that I think that we've still got out there in terms of designing a high performance soil or a healthy soil.
And David.
Well, if Peter thinks worms are exciting, I think sewage is exciting, so I don't know what's sadder, so we can debate that later. Not unrelated. So I'll start with probably the challenge and then the opportunity. So sewage keeps coming at us. It doesn't stop. That's a fact. And so the biosolids that we have then as a result keeps coming out. Our current practice is to distribute that to agriculture. That's becoming, that actually costs us money to do that. And it's actually becoming harder and harder. So the regulations that we have and the draft regulations that we see coming at us will make it virtually impossible to do in any kind of viable way that is actually of benefit to the farmers for the nutrients that they would get out of it. So that's the challenge we have. We've been researching with, am I allowed to mention a university that's not part of the CRC? But we've been researching with RMIT for a while there, pyrolysis technology for converting biosolids into biochar. And so we're well down the track of, we're out of the lab, we've been through the pilot scale, and we've convinced our business to sign $6 million to build a demonstration production plant to produce biochar. As our path forward into agriculture, but potentially other applications as well. It's destroying the contaminants that we're worried about. Heavy metals are still there, but potentially an opportunity forwards. And I've been very encouraged by what I've heard today, the number of, maybe I'm just tuned into it, but the number of times that biochars come up within the research program, that there's active work going on there is really encouraging. See that as a great opportunity to do more, and how can South East Water participate more in that on behalf of the many other, well, every water utility has the same problem. So we're here helping to solve the problem for them as well.
I'll just raise one question to that. I've had many conversations around Australia with the EPAs. I keep saying that if we keep tightening the standards, we're going to become constipated. And seriously, if we don't find solutions, as Dave just said, we're going to have problems all around the world in terms of stockpiles of all this fantastic material, so valuable in terms of what it could do for us, but we've got to solve that problem. And it's like we're involved now, we've actually set up an international alliance of composters around the world. PFOS, PFAS is a major issue. The first subject that we discussed the other night in a link-up of 10, 15 composting associations, PFOS, PFAS. What are we going to do with it? How are we going to ban it? How are we going to stop it? And so if we don't find these solutions, constipated for sure.
I'm going to throw it open in a second, but I'll summarise before I do that. But are there any other comments from you guys based on what each other said? Any comments? Dave, Max?
I'm also excited about worms.
Isn't it good when you turn over a shovel and it's just all the worms are coming through on it?
20 years ago, we started the South Australian No Tillage Association, and the change from the farming techniques we used before, we went into reducing tillage, but then we didn't have the equipment, so we did a lot of burning, and the soils got finer and finer and finer, and eventually we got to the point where we decided that no-till was the right way to go. But to see those soils change and then the worms start to come back, and you can see, look into the soils and see the castings all over the ground, pretty exciting.
So the thing I take out of all that, defining what a high-performance soil is, improving farms to improve the environment, it's what Pete was saying. David, you jumped in and talked about waste, and I take it more than just your waste, but this world is producing more and more green waste, food waste, sewage waste, and that's all got to get turned into product, right? Or it's got to go somewhere. And so the work I think people in this room are doing around that is really valuable, and others, but coming up with products out of that is really important. I've seen work done on struvite before out of waste streams going, well, how do we make it into a phosphorus product? But it hasn't got commercial, right? So it's the commercial buy-in. And all of that comes down to what I think Max and Dave were saying at the start, which is actually this is all about equipping farmers and preparing farmers. It's about the profitability, but it's also about the environment and making sure we do that properly. If we use that, I want to throw it open and see what you guys have questions for this panel for. If I start at that point. Who's got a question? Start with Richard.
Thank you. Very excited to hear the developments with biochar. Really keen to know what sort of price in the market you think is going to work.
Yeah, for you. So, great question. We've had some discussions with, let's call them construction and building. That's a very broad term, but I can't give away too many confidences in that. $200 a tonne for biochar, not out of the question. And we potentially see it going up from there depending on the application that it goes into. What it would look like for agriculture, don't know. That's part of actually understanding the benefits of, the nitrogen, the phosphorus, the pore structure, all the other things that can possibly come with that and how that compares to conventional fertilisers as well. I mean, if we want to take this further, we have vision that biochar could actually make its way into other applications. So again, the RMIT research, still more in the lab scale end. If you run it in a slightly different pyrolysis mode, you actually start to form graphene, carbon nanomaterials. Once you're in that kind of territory, you enter electronics and batteries and energy storage, and then we're not talking $200 a tonne anymore. And thank you, Simon, for raising the point. What comes with this is it's not just pyrolysis, the biosolids, it's also all the other waste materials that, food waste, other organic waste that can come into that to actually produce even better quality materials at the end. Sorry, that was a long answer to probably a short question, sorry.
To give you an idea, I can go and buy biochar loaded on the truck at $100 a tonne at the moment. So if I want to mix that into a compost blend, that's what we can buy it for currently.
Lucas, wait for the mic.
Sorry, I couldn't bite my tongue anymore. So we actually did an economic assessment of biochar back in 2007, I think, and I gave that at the 2009 Asia Pacific Biochar Conference. And some of the biochars are made from manures, and biosolids would be in that similar vein, actually have about $500 worth of nutrient in that. Now, if you're replacing it with urea, with single super, with potash and with lime, it's got a significant nutrient value. But there are other biochars that are made from timber, for example, that have got a very low nutrient value, but they've got much higher carbon value, which is valued quite differently. So the value of biochar really comes down to how it's used, why it's made, and there are circumstances where biochars are just made for the sake of making biochar. But I think you find that the majority of chars now are made as an integrated process. So where they're separating hydrogen gas, where they're taking waste product, where they're co-generating electricity from the leftover methane and carbon monoxide. So there are a whole stack of income streams from the pyrolysis process depending on your level of engineering and your purpose. So it's not just, we just really need to point out it's not a single product, it's not a single process, it's a whole scope of different things that can be done. And yeah, the dollar value, which is a really important question around the field economics of it, come down to what you're using it for. And from my opinion, I think a lot of the future uses of biochar will be as bespoke or specialised products that are designed for a particular purpose, as a fertiliser carrier, as a carrier for gypsum, as a redox modifier in soil, for acid soils, for sodic alkaline subsoils. We've got a really good understanding of where that's going. So yeah, and there are businesses now starting to develop these products, which is really good. Sorry for my rant.
That's fabulous commentary, Lucas, and thanks for that. And that's one of the reasons why we're here, so we can tap into some of that experience background that's going on, and then actually what are the gaps now that we need to fill to actually do that. Probably the other one I'll just throw into that is we're still just trying to get our head around how does potentially carbon trading and the dollar value of carbon in the total system as well, what's that worth to us as well. So complicated, integrated, all of that, but exciting at the same time.
Hey Pete, you mentioned about PFAS. there's heaps of emerging other PFAS compounds such as Gen X, PF, NS, and they're almost impossible to detect through chemical analysis. How do you think you're going to manage these compounds, and also to the sewerage as well with David?
I'm not a scientist. I've got no idea. But I was at a presentation that Mike McLaughlin did a few months ago, and it's quite scary. I don't really know. Hopefully you scientists in the room are going to come up with a solution, because I'm very, very concerned about where we're heading in this area, because I just see it, again, with this International Compost Alliance, in Maine, in USA, they've just banned biosolids being spread. A composter in USA is just made to clean up his site and the waterways because of PFAS. I mean, God almighty, where's it going to end up? I don't know. And if these things that you're talking about are worse, help.
Yeah, great question. And more of these compounds seem to be emerging, and their breakdown products as well. It is pretty scary. For us, some of our, we call them trade waste customers that enter our sewage system are landfill sites. And landfill sites are full of PFAS. And so we take their leachate, their stormwater runoff ends up in our system. And so that is just a gift that's just going to keep on giving for a very long time. And so the range of solutions we're going to have to look at over time is going to be pretty interesting. So biochar, yes, the pyrolysis destroys, certainly removes it. There's still a little bit more research on the final destruction of it, but then what about some other non-thermal processes as well? So interesting times ahead on that, but yes, PFAS is bad. Let's not lose sight of emerging pharmaceuticals, other emerging chemicals as well, and not miss that wave that swamps us as well.
I think one of the key parts of that is we might not know the answers, but we actually have to solve those problems.
Yes.
We talked about carbon before, we talked about some of the challenges with use of chemicals in the EU and so forth. We have to solve these problems. Is there another question first before we come back to that? Got another question out there? And I'd encourage everyone to come and have a chat with these guys over dinner at the end of the day, because there'll be some really technical things you might want to talk about as well.
Hi there. This is a question for David. Just following on to what James was saying. PFAS is a problem. We all know it. I was just wondering, is there legislation in Australia to say, this is a sort of concentration of PFAS, other sort of compounds that we have in biosolids and in wastewater? Because I think in the US, the concentration of PFAS in US drinking water is like 0.000 something ppm, and that's fine to drink for the public.
We're less concerned about those materials in drinking water. They're easy to get out of. They're not particularly water soluble, not so much of an issue. Majority of it ends up in the biosolids. So there is, now Aravind knows this stuff better than I do, so ask him the questions over dinner on the detail of this, but there is regulation around how much PFAS in soils, and hence how much biosolids you can put in soils. And I was mentioning earlier, the latest drafts of that are coming through, it's becoming more and more restrictive to the point of it's not going to be viable anymore.
I understand the new NEPM 3 is just about to be released any minute, so that should give you a bit better understanding of what we're allowed and what we're not allowed.
Thanks. You mentioned heavy metals earlier. I know in certain parts of Europe there are areas like that do have quite heavy concentrations of cadmium and other things, which is a concern. Could you perhaps offer some more commentary on the effects of that and how that's going to be dealt with in the... I think you said it wasn't going to be, so what are your thoughts on how to manage that going forward?
Yeah, great question. Again, part of the catchment that we have is somewhat industrial, including those landfill sites. So we do end up with heavy metals in our sewage, in our biosolids. Pyrolysis doesn't remove those. They're not volatile kind of compounds. So we do end up with those in the biochar. So we know that through our scale-up process. Some of those, it's interesting who you talk to. Some in the agricultural world say, oh, a bit of copper and zinc, that'd be pretty good. But not so good cadmium and other things like that. So that's something that's ongoing research for us in that space. Co-pyrolysis with other materials, such as some of those food wastes, can help make a product that might be more suitable for us. Post-blending as well, possible, if we can, selective extraction of some of the nastier heavy metals. Still plenty to do in this space on that.
Any questions for Dave or Max?
Hello. My question is regarding this recycled water, and because we did a scoping study in South Australia, how we can use this water for growing crops and horticulture crops, all those stuff. And apart from this recycling water A, B, C, so we just get rid of this E. coli, heavy metals, but still there is one thing, the soluble component of ions. So that is the calcium, magnesium, of chlorides, sulfate, and all that stuff. So that the limit is 1200 milligram per liter. But even if we have that limit and we are using that water for maybe 10 years, 15 years, so still we have problems of salinity and sodicity in the soils. So what do you think, whether we need some more robust kind of recycled water analysis, or we need more kind of like maybe A+ water so that we can deal with those issues as well? Thank you.
Wow, okay. Class A recycled water, that's regulated as well. We have certain limits in those space. Some of the best use of that Class A water, I would almost put that out to the room to, can you help with the answer to that question as well? Probably, and I won't answer that one directly, it is beyond my knowledge as I sit here now, but I think others in the room might be able to help with answering that one. What I will throw out there is actually the vast majority of the Class A water that we produce, well, we have to produce Class A water. It's part of our mandate. The vast majority of that goes to ocean outfall. Bypasses all the agriculture down the Mornington Peninsula. Central and South Gippsland goes to ocean outfall. They're absolute waste. So in terms of that circularity of the economy, we've got to be doing better to do something more with that Class A. And if it's about we need to improve the quality in certain areas to do it, fantastic. Let's hear it. We don't regulate that, but we can push on that in that direction to see how we can improve it. So sorry, I haven't exactly answered your question, but some commentary anyway.
Oh, hi, Marcus Hardy from UTAS. I've got a growing suspicion that one of the future issues we're going to have to start addressing is plastics in soil and microplastics. Soil is one of the few environments in which some plastics will actually break down, but at risk of breaking down to products that are more harmful than the plastic to begin with. But at the end of the day, plastic in soil might be a better solution than plastic in our waterways and our marine environment. So I was hoping someone could speak to the issue of plastic in soil and whether you guys see it as an emerging issue. Thank you.
Comments, David?
Do you want me to? I just had to nick out earlier to go and have a meeting with the EPA here in South Australia. I met with CSIRO because they've actually put up for a CRC for plastics, and part of that is looking at microplastics and what can be done about it. They didn't get in the first round. I think they got to the fourth round, so they're going to put back into it to see if they can actually get that up. And part of that is trying to find solutions in terms of what can be done with microplastics. I think Thomas Foods up in Murray Bridge have actually got an anaerobic digester, and they're putting bugs in there at the moment that they seem to be thinking that they've got good result, that those bugs are breaking down the plastics. Where that goes, where's the science in that? I think there's plenty of opportunities with that. With many of the professors and that I talk to, there looks like that could be one of the potential. There's also a CRC for SAFE that's got up for antibiotics and et cetera, et cetera. So I think when you pull all these CRCs together and look at where we're going for healthy soils and all the rest of it, I think in the near future solutions will be found for these things, I think, because we have to do something. We just can't sit on our laurels and not do something. We have to do it.
I think I'm going to grab that too, Marcus, because Ben mentioned it before, but there's legislation come through in the EU about the use of plastics in agriculture in the EU. Was spent some time over in Europe earlier this year looking at that, and nobody really has the answers yet. But there's a definite push on to reduce how much plastic disappears in agriculture. Someone earlier mentioned to me microplastics as carriers in the microbial space, and you know what? We're not looking at plastics as carriers in the microbial space because they're going.
Yeah.
Legislation, social expectations will take that out. It's really interesting to see the conversation around the use of biosolids because there's social expectation that comes with that. There's legislation that comes with that. These are things that we have to address as a science community. I'm going to close it off because, well, we're out of time. But each of these four represent partners within the CRC. There's a whole lot of knowledge sitting up here. There's more knowledge about to come up when the grower groups have their panel session. But it's about collaboration, utilising it. Some of you will know these people up here, many of you won't, in different contexts. So yeah, take the opportunity to get to know them and build on the relationships you've got here. Thanks, guys.
Thank you.